Hey everyone, it's Emily with Spiceworks. Thanks for tuning in today and joining us on another Spiceworks Partner Webinar. Beef up your security with Risk-Based Plan, brought to you by First Communications. Before we get started, I want to remind everyone of the Q&A box on your screen to the left. We encourage you to submit your questions at any time during the presentation. First Communications will be able to follow up with you regarding any questions you may have. So now that all the housekeeping is done, I'd like to introduce our presenter, Miguel Sanchez, Senior Sales Engineer with First Communications. So Miguel, whenever you're ready, take it away.
Thank you for the introduction, Emily. And again, welcome everyone to First Communications presentation on risk-based security and self-protection. For those who are not familiar with First Communications, we'll take a quick glance at the company. Our mission is to empower our customers through leading-edge technology solutions delivered with a first-class experience. We've been around since 1998, serving thousands of businesses throughout the Midwest. We have a 24/7, 365 days a year network management center. We have data center and co-location facilities in Cleveland and downtown Chicago, headquartered in Akron, Ohio, and serving diverse businesses ranging from SMB to enterprise accounts such as Advocate Sherman Hospital, the Private Bank, Grubhub, First Energy, and Akron Children's Hospital. Today's agenda will include a current state of information security and an overview of risk-based security models, risk management process, the multi-tiered risk management model, which correlates to the 3 levels of risk management, and then we'll touch upon runtime application self-protection. The threat landscape has changed considerably over the past few years due to the disappearance of the perimeter defense for the following reasons. Change, such as new product launches or the introductions of new technology, are all on the rise, having a complicating impact on the strength of cybersecurity. Mobility and consumerization. The adoption of mobile computing has resulted in the blurring of organizational boundaries. IT is getting closer to the end user and further from the organization. The use of the internet, smartphones, and tablets, in combination with BYOD, has made organizations' data accessible everywhere. Ecosystem. We live and operate in an ecosystem of digitally connected entities, people, and data, all increasing the likelihood of exposure to cybercrime in both the work and home environment. Cloud-based services. Third-party data management and storage open up new channels of risk that previously did not exist. It is very common to hear about security concerns for shadow IT. Infrastructures for traditionally closed operational technology systems are now being given an IP address. Cyber threats are now making their way out of the back office systems and into critical infrastructures such as power generation and transportation systems, which of course is a very high concern for Homeland Security. The growing attacking power of cyber criminals has increased significantly and are not just some hackers operating out of someone's basement anymore. We need to take into consideration the following threats. Criminal syndicates. Dell Secure Works has reported over 830,000 victims of the CryptoWall ransomware, with demand starting at $500 each. State-sponsored attackers. We keep hearing about state-sponsored dedicated denial service attacks by Russia or China. Hacktivists such as Anonymous making political statements. And lastly, the lone wolf hacker or black hat who is just having some malicious fun. The attacking power of cyber criminals is increasing at an astonishing speed. Attackers have access to significant funding. They are more patient and sophisticated than ever before, and they are looking for vulnerabilities in the whole operating environment, including people and processes. So, what are the defenses currently in place? Firewalls were first widely deployed network security technology when the internet was a baby. Its basic job is to inspect that traffic and to decide what traffic is allowed to go from the outside inside and from inside to outside. However, network traffic has changed quite a bit in the past couple of decades. In addition to firewalls, traditional responses to new threats has been to add standalone security technologies to the network. Unfortunately, this adds complexity and cost, as each new technology means a new device to deploy, a new set of policies to configure, and a new management console to monitor. In response to the limitations to the traditional method of network security, next-generation firewalls have evolved to fill the need. There's been tremendous advancements in next-generation firewalls that should be part of any information security plan and include the following UTM capabilities: naturally stateful packet inspection, anti-malware, anti-spam, intrusion detection prevention, VPN, content filtering, to name just a few. Next-generation firewalls, or web application firewalls, are an important part of an information security plan, but not the end-all be-all. It becomes an important part of an information security architecture. For most small to medium organizations, information security is a reactive versus a proactive process. How many breaches do you hear in the news of compromised systems that are discovered weeks or months after the actual event? How do we avoid the recent data breaches of Sony Entertainment or the healthcare provider Anthem? For example, in Anthem's case, they are considered HIPAA compliant, but their data was not encrypted because it didn't need to be. Being compliant does not mean you avoid or mitigate risk and the impact or consequences that will be experienced. So what are some of the constraints for implementing effective information security? IT departments have shrinking budgets. In addition to less money, IT is given more responsibilities. A lack of security focus. Not every organization has a dedicated security team. Lack of resources. It could be a shortage of staff or lack of training. Lack of a common approach to information security. Being reactive versus proactive. This is where having a framework is necessary to help identify your cybersecurity risks. There has been a steady and slow change at the way organizations approach information security using a risk-based model. Today, CSOs, CISOs are being asked to prioritize risk by identifying which ones need to be addressed and which ones should be accepted as a cost of doing business. So what are some of the factors that drive a risk-based security model? Compliance is a big factor for heavy regulated industries such as healthcare and financial institutions. It could be a recent security event. It could be internal or external. The threat landscape, recently issued threats or assessment of a new risk. Proactive approach, companies that are leading edge or want to do the right thing. As you can see from the survey, compliance has the greatest response for a risk management program. But it becomes just one factor in the risk profile. Even in a risk-based program, compliance doesn't go away entirely, with the regulations still being there. Department heads and managers have to start thinking in terms of acceptable risk levels versus compliance requirements from a checklist. It's a change in mindset of an organization. It is an aha moment for the entire organization when everyone understands what the difference is. Let's take a look at what you get with a risk management model. Risk management is the ongoing process of identifying, assessing, and responding to risk. Looking at managing risk, business and organizations need to understand the likelihood or the probability that an event will occur and its resulting consequence or impact. Risk tolerance. Using a risk management model, organizations can determine the acceptable level of risk for the delivery of services, and this can be expressed as their risk tolerance. Tolerance for risk changes over time. It is dynamic and fluid. There are several risk management frameworks that organizations are using, including some from NIST, ISO, PCI, HIPAA, internally developed systems, or combination of others. For this discussion, we'll be using the NIST Special Publication 800-39 framework. Managing risk is a complex and multifaceted process. It requires the involvement of the entire organization using a multi-tiered risk management process. It needs the involvement from senior leaders, executives providing the strategic vision, to mid-level leaders planning projects, to individuals on the front lines operating the information systems. Risk management is a comprehensive process that requires organizations to assess risk, or basically establish context for risk-based decisions, assess risk, respond to risk, and monitor risk on an ongoing basis. The risk management process model shows a continuous loop feedback across all levels, where the risk frame is defined at the strategic level down to the front lines where information security systems are monitored. The first component of risk management addresses how organizations frame risk, or the risk context. The risk context is the environment in which risk-based decisions are made. So establishing a realistic and credible risk frame requires organizations to identify the following: the risk assumptions, the risk constraints, risk tolerance, priorities and trade-offs. The purpose of this step is to produce a risk management strategy that addresses how organizations intend to assess risk, respond to risk, and monitor risk. The risk frame establishes a foundation for managing risk, and the boundaries for risk-based decisions. The second component of risk management addresses how organizations assess risks within the context of the risk frame. The risk assessment component identifies threats to organizations or threats directed to organizations against other organizations. For example, an attack on your information systems to gain access to one of your outside vendors through a company portal. Vulnerabilities, internal and external. Could be people, could be systems. The consequences or impact that may occur given the potential for threats exploiting vulnerabilities. And lastly, the likelihood that harm will occur. The end result is a determination of risk, or the degree of harm and likelihood of harm occurring. The third component of risk management addresses how organizations respond to risk once that risk is determined based on the results of risk assessments. Its purpose is to provide a consistent organization-wide response to risk in accordance with the organizational risk frame. So again, everything revolves around the risk frame. It's going to be the one constant in all these different models. So we have to look at developing alternative courses of action for responding to risk, evaluating those alternative courses of action, determining appropriate courses of action consistent with organizational risk tolerance, and implementing risk responses based on those selected courses of action. To support the risk response component, organizations describe the types of risk responses that can be implemented by either accepting, avoiding, mitigating, sharing, or transferring risk. As you can see, everything revolves around identifying the risk frame which drives all other decisions. The fourth component of risk management addresses how organizations monitor risk over time. The purpose of this component is to verify that planned risk response measures are implemented and information security requirements are satisfied, determine the ongoing effectiveness of risk response measures following implementation, and identify risk-impacting changes to organizational information systems and the environments in which the systems operate. Here we come back to the risk management process model, where the frame risk is at the center of the whole process. Basically, we start with identifying what is of value for an organization and the risk associated with that valuable asset. How do we make risk management work? It can be broken down into three distinct areas. Tier 1, organizational or strategic level. Tier 2, mission business process or the tactical level. And lastly, Tier 3, information system or the operational level. The risk management process is carried out seamlessly across the 3 tiers with the overall objective of continuous improvement in the organization's risk-related activities with effective communication across all 3 tiers and among all stakeholders having a shared interest in the success of the organization. The multi-tiered risk management approach has distinct boundaries and accountabilities with continuing communication across all tiers. From the organizational level that frames risk, to the mission business processes that assess and respond to risk, down to the operational level where risk is monitored. Again, as you can see, inter-tier and inter-tier communications is continuous feedback loop for improvement, and there's traceability and transparency of risk-based decisions. So we'll take a look at Tier 1, the organizational level. The organizational perspective that establishes and implements structures for governance, which is a set of responsibilities and practices exercised by those responsible for an organization, such as the board of directors and or executive management. The risk executive function serves as a common risk management resource. It is similar to the recommended executive position in disaster recovery business continuity planning. They are the single point of contact between various departments in this collaborative process. Risk tolerance is a level of risk or degree of uncertainty that is acceptable to organizations and is a key element of the risk frame. Investment strategies that generally reflect the long-term strategic goals and objectives of organizations. Next is Tier 2. Tier 2 addresses risk from a business process perspective by designing and implementing business processes that support the business functions defined at Tier 1. So again, we go back to Tier 1, the organizational, the strategic level. We look at risk-aware mission business processes is one that explicitly takes into account the likely risk such a process would cause if implemented. Implementing risk-aware mission business processes requires a thorough understanding of the organizational missions and business functions and the relationship amongst those functions and supporting processes. Enterprise architecture establishes a clear and direct connection from investments to measurable performance improvements. It promotes the concepts of segmentation, redundancy, and elimination of single points of failure, all concepts that can help organizations manage risk more effectively. The information security architecture is an integral part of the organization's enterprise architecture. It represents that portion of the enterprise architecture specifically addressing information systems resilience and providing architectural information for the implementation of security capabilities. The primary purpose of the information security architecture is to ensure that mission business process-driven information security requirements are consistently and cost-effectively achieved in information systems. The environments in which those systems operate are consistent with the organizational risk management strategy. Information security requirements defined in the segment architecture are implemented in the form of management, operational, and technical security controls. It provides a detailed roadmap that allows traceability from the highest Tier 1 strategic level down to Tier 3 operational level. Here you see information security architecture flows from the organizational strategic level and into the environments of operation in the multi-tiered risk management model. Now let's take a look at Tier 3 information systems view. The risk management activities at Tier 3 reflect the organization's risk management strategy and any risk related to the cost, schedule, and performance requirements for individual information systems that support the mission business functions of organizations. Risk management activities are also integrated into the system development lifecycle of information systems at Tier 3. All information systems, including operational systems, systems under development, and systems undergoing modification are in some phase of the system development life cycle. There are typically 5 phases: initiation, development/acquisition, implementation, operation/maintenance, and disposal. So when we look at the multi-tiered risk management model, it's very similar to the 3 levels of risk management in a lot of other different models with the following correlation. Tier 1 organization sets risk management strategy. Tier 2, the business processes, tactical architecture. Then Tier 3, your information systems, processes, operational level. So this slide shows the integration of the risk management model with the multi-tiered risk management process. As you can see, everything revolves around the frame risk component. The bidirectional arrows in the figure indicate that the information and communication flows among the risk management components. The execution order of the components may be flexible and respond to the dynamic nature of risk management process as it is applied across all three tiers. So as you can see, the strategy is set at the organizational level, which moves to the assess component, to respond component, to the monitor component. Any changes in the model is easily flexible and can be put back into the frame risk component to assess, respond, and monitor that new risk or changes in the nature of that risk. When we look at the NIST cybersecurity framework, it has direct correlations with the risk-based management model with the multi-tiered management approach. It has distinct boundaries, but is collaborative and flexible. So how do we get started? We're going to take a quick look at a sample outline that can be used for implementing a risk-based security plan. So first, we got to identify what is a value, what matters. Collect the data on that value. Perform a risk assessment. Naturally, we got to present it to the organization. Identify control objectives. Identify and select controls. Implement the controls. Operate those controls. Monitor and measure. And then lastly, operate a feedback loop. So we have to identify what is a value or what matters. If you have a disaster recovery business continuity plan, then you have already started to identify critical information systems that need to be prioritized. This can help in the identification of risk to that value. Tangible versus intangible assets. Many of the most valuable assets are intangible and are typically not considered in technical approaches to information security. A company's reputation is considered an intangible asset, so how do you place a value on that asset? Maybe we need to ask the target for the value of this intangible asset. I suppose closing 140 stores nationwide provides a good number. Collaborative effort. This requires us to step out of our techie role and step into that of a sociologist. We need to survey the organization and engage those who are responsible for each line of business. We need to gather information about the organization's revenue stream, its revenue per line of business, how each business unit is interrelated and can impact the revenue stream. We need to learn what the manager focuses on to keep their area running. Then we have to collect data on that asset, an asset evaluation, the impact to that asset, the threat landscapes, the frequency and likelihood of risk, the vulnerabilities. Nearly all risk analysis methodologies require key pieces of information in order to complete the analysis. Collecting this information is a process best based in observable data, and it can include feedback from the organization's environment or be based on broader industry studies. The information collected does not need to be absolute and precise, and in some cases the data collected will be closer to estimations. It is important to start with a baseline that will evolve over time. Next, we perform a risk assessment, which is a critical junction of any risk management program. It is where the various elements that affect risk are brought together and the data that has been collected is exercised. The first step is to set the objectives of the assessment. The objectives should specify the environment and assets being assessed. Some of the things we need to look at for the methodology to assess risk are the need to represent risk as a balanced combination of threats, vulnerabilities, and likelihood. Consider a broad range of viable threats, likelihoods, and vulnerabilities. Measure risk using as much tangible data as possible. Do not attempt to be absolute or force precision, but rather attempt to define the probability of events and outcomes. Create meaningful analysis of probabilities. What is the likelihood of something happening, rather than possibilities, simply what can and what cannot happen. Create meaningful information on the magnitude of an event and its impact. And lastly, rank risk based on a normalized scale that is explicitly defined, relevant, and reusable across risk analysis of all sizes and types, similar to the disaster recovery business continuity prioritization of information systems. Then we need to present to the organization. We have to present key risks to the achievement of organizational goals. Remember, it is an open, collaborative discussion. And again, it's not a precise prediction of the future. Ultimately, all decisions about the treatment of risk are up to the owners of that asset. Therefore, the material needs to be presented in a manner that makes the stakeholders better able and enabled to make informed decisions. And let's take a look at the next step, identify control objectives. A control objective will identify the risk being addressed and will identify ways that minimize an element of that risk, whether it's reducing threats, frequency, or likelihood, or mitigating the vulnerability that makes the threat viable. You need to take a look at the best solution, not just a vendor-specific solution, but it could be a combination of several vendors or some internal solutions. Remember, it's the best solution for your organization, not what the best solution is recommended by a specific vendor who wants to make a ton of money. Identify and select controls. What is the total cost of ownership of the control? Besides simple capital costs, what are the long-term costs of maintaining the control? What are the labor and maintenance costs? What are the costs of upgrades, changes, and development? How flexible is the control to changes in the organization or the elements that make up the risk? Is the amount spent on the control going to be appropriate for the probable magnitude and impact of an event? And if inserted back in the risk analysis, does the control reduce the risk by an expected amount? Then we have to implement controls. Ensure that implementation follows the objectives and requirements previously set. As with any project, it is important to ensure that the implementation follows the objectives and requirements that were previously set forth. Operate controls. This step is one that we are also very well acquainted with and does not operate controls differently than any non-risk-based methodology. Risk-based security management does, however, take an additional step that measures the effectiveness of the controls itself and its operation. Then we need to monitor and measure. Measure on an ongoing basis. In order to validate that the control is satisfying the intended objectives, it is critical to measure on an ongoing basis the effectiveness of the control in relation to the original risk it is designed to mitigate. The measurements must focus on clearly identifying changes in risk. Then lastly, operate a feedback loop. Risk-based security management is cyclical and ongoing. Data collected should create a feedback loop. When we talk about cyclical and ongoing, initially when you're starting this plan, you might be looking at this at every 2 months, every 3 months, and then eventually every 6 months doing these assessments and identifying any changes in risk. So again, it's going to be cyclical, it's going to be an ongoing basis, and it's not something that's going to be statically set. So again, we'll go back to the NIST cybersecurity framework. And again, the idea is that this is a flexible model that addresses current identified risk and any future risk that might be identified through this model. Risk management is an evolution. So as you can see from this slide, it becomes informal, incident-driven maybe, like you're in a hamster wheel. Then it maybe becomes service-oriented with risk analysis for services. The hamster wheel is analyzed for risk. Security becomes part of the cycle, but still is a problem. Eventually to market-oriented, where security is truly embedded in all the different departments and throughout the organization and the different processes. Up-and-coming technology for information security. Some of the more recent options for helping and implementing a risk-based security model could be runtime application self-protection. Realistic detection rates for today's advanced threats are typically around 5 to 10%. We need to accept that, just like us, our computers cannot distinguish good from bad. Antivirus and other security products that claim to be able to detect malware quite simply cannot keep up. Compounding the security threat to applications is a heavy reliance on mobile devices for access and the use of these mobile devices within the enterprise network. The BYOD growth has helped fuel some of the growth in the perimeter security spending increase, but perimeter protection simply won't cut it in today's intrusion landscape. Applications need self-defense, or as Gartner calls it, runtime application self-protection. So runtime application self-protection. The next layer of information security, it is a security technology that is built or linked into an application or application runtime environment and is capable of controlling application execution and detecting, preventing real-time attacks. It is like learning karate for self-defense and not waiting for the local police to arrive before it's too late. Imagine what happens to malware that just bypassed the IPS on a new next-generation firewall, but the application defends itself against it. RAS runs on the application server and monitors the execution of the application from the stack. It protects from within the application, utilizing contextual insight so that you can be confident in identifying and stopping attacks that network security cannot see. Gartner predicts 25% of web and cloud applications will become self-protecting, up from less than 1% today. Applications should not be delegating, as is done today, most of their runtime protection to external devices. They should be capable of self-protection, that is, having the protection features built into the application runtime environment. These features should see all data coming in and out of the application, all events affecting the application, all executing instructions, and all database access. Once runtime application self-protection, or RASP, is deployed into production, the application runtime environment should be able to detect attacks and protect applications with a high level of assurance. As with any new technology, it does have its drawbacks. It can be a performance hit. I've seen anywhere from 5 to 10%. Its implementation is limited currently to web and in virtualized environments. Not sure about legacy applications, but that was also an issue back in the day when server virtualization started taking off. So in conclusion, a risk-based security model helps to provide a flexible, fluid, and ongoing information security framework that needs collaboration. It's a different perspective on information security. It is that aha moment in an organization when they realize what is the difference between risk-based models versus traditional models. Again, there are various models to accomplish an organization's overall strategic objectives for effective cybersecurity or information security. And lastly, runtime application self-protection is an emerging technology that can address the quickly disappearing perimeter for information security. It's a new technology, and it'll be interesting to see how it takes off in the next couple of years. And with this, I thank everyone for attending the presentation. Again, this is Miguel Sanchez, Senior Sales Engineer with First Communications. My contact information is on the slide and will be available through Spiceworks after this presentation. Again, thank you everyone for attending the presentation.
What an awesome presentation. Thank you, Miguel. I hope everyone was able to learn a bit more about how to beef up your security. Special thanks to First Communications for sponsoring today's event. Also, thanks to each and every one of you for tuning in today. We hope to see you back soon for another Spiceworks Partner Webinar. Until then, stay spicy.